this is the problem that I was assigned. You can go ahead and pause to read all of it. So basically the problem says that there is 500 milliliters of nitrogen gas, liquid nitrogen, and that the rest of it is nitrogen gas. So that means that there is 1,500 milliliters of nitrogen gas, and that you decide to drop a piece of iron into the thermos, and then it asks what is the final pressure. So to solve, we could use the ideal gas law, and we would need to find what the total number of moles is, what the temperature is, and what the total volume is. So how can we find the variables that we're missing in order to be able to use the ideal gas law equation? So to find the total volume, we could say that the total volume is going to be equal to the initial volume plus the final volume. We were given the initial volume, but we don't have what the final volume is. But to find the final volume, we could use this equation, or V2, we could use this equation, which is the total mass of nitrogen divided by the density of the nitrogen. And to find this, we would have to use this equation. We don't know what the heat energy transferred is, but we do know what this L is, the nitrogen heat of vaporization, which I know is this value. So, but to use this, first I would need to find what the heat energy transferred is. And to use this equation, I have all the values that I need. M is the mass, and C is the specific heat of iron, which I know is this, and I have these values for the temperature. To find N1, I could use the ideal gas law equation, say that N1 is going to be equal to P1 times V1 divided by R times T1. I already know what all these values are because I have above what the initial pressure is, I have what the initial volume is, and I also have the temperature, and I know the ideal gas constant. And to find N2, which is the number of moles that are added, I would get the number of moles of nitrogen that we have and divide it by the molar mass of nitrogen. So now that I've figured out my strategy up here, I can begin by solving for the total volume that I have. So first I need to use this equation. So if I plug in all these values, which I had already written down, I'm going to get that is equal to 1.97 times 10 to the 4 joules. And then I can substitute this value into this equation. I already had what this value is, and so I'm going to get that we have the mass of nitrogen that we have is 0.99 kilograms, and I can use that to find what the volume that is added is. And so I'm going to get that if I divide the mass of nitrogen divided by the density, I'm going to get that it's 1.22 times 10 to the negative 4 meters cubed, and then I can add the initial and the added volume to find the total volume, and I'm going to get that it's 1.62 times 10 to the negative 3 meters cubed. So now I can solve for moles. So the number of moles is going to be the mass of nitrogen divided by the molar mass, which is going to give me that I have 3.54 moles. And then to find the number of moles that are added, I would use this equation, which I said was the ideal gas law equation, plug in all the values that I had already written down, and I'm going to get that 0.237 moles are added, and then I would just add N1 and N2 and get that the total number of moles is 3.78 moles. Now I can finally calculate the final pressure since I have all the values that I need. So I just plugged in the total number of moles, the ideal gas constant, the temperature, and the total volume. So I got that the final pressure is going to be 1,490 times 10 to the 3rd pascals.